Welcome to Decoding Healthcare Research. I'm your host, Efrain Riveros, Dr. E.F. Rain. Today we will talk about longevity, as particular aspect of longevity that has to do with the existence of centenarian people and the reasons why this happens, and an epidemiological study that was conducted, probably the largest in the world, addressing this issue. And for that reason, we have the honor of having here two researchers from the Institute of Environmental Medicine at the Karolinska Institute in Sweden. We have with us Dr. Shunsuke Murata and Dr. Karin Modig. Welcome you both.
Thank you. Thank you for the invitation.
Thank you so much. So we are going to be discussing a paper that was published in 2023. The title of the paper is Blood Biomarker Profiles and Exceptional Longevity, Comparison of Centenarians and Non-Centenarians in a 35-year follow-up of the Swedish AMORIS cohort. So first of all, I want to start giving a little bit of a background. Living for more than 100 years used to be something exceptional, but it's becoming relatively more common with time, to the point that, according to your paper, it is projected that the amount of people going past 100 years of age is expected to multiply probably 5 times in the next 30 years. So my first question is, what is the line of research of your work and how does it intersect with longevity?
Yes, so I had this small research group which we call Aging and Health, and we have a few research lines, but the overarching theme is population aging and what's the cause of that and what's the consequence of that, so to speak. And we are epidemiologists, but we of course collaborate and work with medical doctors, but also demographers. And depending on the research group, we have different angles. But with regards to longevity, which is a main topic and interest of the demographers, we have conducted some studies where we look at longevity development and the driving cause of that, and what if we see sort of a leveling off of mortality rates at the very highest ages and so on. And with the medical doctors, we more work with the questions of what is driving this increase over the recent decades. And of course, there are many aspects, but I think different factors have contributed differently also over time to this. And at least for Sweden, we have seen that it is for sure mortality improvements up to the age of 90 that has, up until now at least, been the main driver of the huge increase in centenarians. Because once a centenarian, we haven't had any improvements at all in Sweden in terms of their mortality rate. So it is that we increase the denominator, the population, almost at 100, that so statistically increases the chance of someone becoming 100. It seems we are starting just now, just the latest years, to see a change in this, that we actually also see an improvement above age 100. But this is sort of the background of this research line. And from this, we have also stepped into the question of what characterizes people that are exceptionally old. And there is this debate going on, you know, over the life course. Is this something that you completely decide yourself based on your lifestyle and your life choices, or it's completely, you can't do anything, it's a genetic lottery, or it is just pure chance at some point? And I think all of this contributes, and we are interested in, you know, at also over the life course and over at different ages, which of these factors are most important.
I see. And other groups have tackled similar questions from the clinical standpoint, but you guys decided to focus on biomarkers in this study. Is that correct?
Yes, and we have a very clear population perspective. So we are not working with individuals and individual factors, but we try to address populations and see what we can address for a group of people.
Okay, and before we go deeper into the paper, my question is, you know, as people get older, after they become centenarians, what is the expected quality of life in terms of health status? So in the observations that you have made over time.
Yes, so we work primarily with quantitative data, which means that, I mean, quality of life is in essence a really subjective parameter, something you have to ask every individual about. Okay. And these type of data is more rare, but of course you can measure or estimate quality of life also from some quantitative data, for example, based on illness, based on number of drugs, based on how you live perhaps, and so on. And Shun and I have also done a parallel paper with the one we are discussing today that describes the centenarian population of Sweden, and Shun is also working with a comparison to the Japanese centenarian population. But what we see from Sweden is that this population, which is up until now at least described in public media as a very strong group. You can see pictures where they parachute, where they run, and where they are very active and healthy. It's not a representative picture of this group. Actually, they are rather multimorbid. More than half of them live in care homes, and the majority suffer from polypharmacy. So I think we conclude, Shun, you correct me if I'm wrong, that only about 2% of the Swedish centenarian population today can be, based on these morbidity and drug measures, be classified as healthy and independent. But having said that, of course, they can have a good quality of life in other aspects, but they are for sure not healthy.
Perfect. So let's go into the study. So what were the research questions that you guys wanted to answer with this paper?
Yes. So the question is, when we look at people, so there are a number of studies where researchers look at centenarians or very old people and the characteristics of them, and compare to people that are not that old or that did not become that old. But typically this is done then in a cross-sectional way, and it's difficult to know what selection gave to this. So what we were interested in knowing at very earlier ages, is it still possible to observe difference between those that will become very old and those that won't? So this was the driving question. And also, if we observe these questions already at age 60, if we see it at age 90, so is there an age where we no longer observe any difference? That was the drive. And I mean, it's a methodological problem that you sort of condition on survival or death in that case, but I can't see any other way out of it. With the research questions that we had.
Absolutely. And how did you pick the biomarkers to be measured?
Yeah, so this cohort that we have used was originally just a laboratory database of the region of Stockholm in Sweden. So at the time, which is in this case 1985 to 1996, so during this 11-year period, the vast majority of any blood sample taken in region Stockholm was going to one single laboratory called K-lab. And the majority of the blood tests in the whole cohort are actually coming from work assessment tests through workplaces, just regular health checkups. But for our specifically very old people, many of the tests are also coming from primary care. So this means that it's a really unselected group of people. It's just everyone living in Stockholm that ever gave a blood sample. And this database was then donated to the university, and a lot of registers were linked to the individuals and was then turned into a research cohort. And we selected the biomarkers based on sort of a standard set of markers that were taken for the majority of people, especially for this health checkups data. So there are many, many more biomarkers in the cohort, but then fewer people have assessment. So we chose common biomarkers that are usually like a standard procedure taken from many people.
I see. And how big was the sample? How many patients had the information relatively complete?
I leave this question to you, Sean.
Yeah, our study included about 45,000 of older people, and we analyzed their participants.
Okay, and what you mentioned that the lab tests were taken like for the same patient happened several times. So tell me a little bit more about the database so that we have more clarity before we go into the actual measurements.
Yes, so many people have many repeated measures, but for this specific study, in the base analysis or the main analysis, we have only used the first measurement of each person. We did some sensitivity analysis, which are in our appendix material, where we looked at the repeated measure for a couple of biomarkers. But the main analysis, we only used the first measurement for each participant.
Perfect. So let's, because I think it's exciting what you guys found. Let's move on to the results part. What did you find as a result of your analysis?
Yes. So I mean, the main focus on this paper was actually rather descriptive. So it's also why we look at many biomarkers and not focus deeply on one or so. And we wanted to look at profiles first. And we, of course, discussed a lot back and forth how you describe such profiles or how you approach this method. But in the end, we ended up with the figure 1, where we show distributions of the markers with a median and the quantiles. And what we find in this figure 1, it's actually several things I think that this figure display. It displays that overall, or generally, the people that eventually become centenarians, they have more compressed values of the markers, meaning that they more seldomly have adverse level or very high or very low values of the markers. We also see that the medians rarely differ much, but it is actually the lowest or the highest quintile that constitute the difference. And this, I think, is important to know when, also in future study, when we look and compare people of old age with others, that medians and means are typically not the best measure to compare, but rather other ends of the distributions. We also saw that for some markers, the differences seemed to be larger than for others. And finally, in the figure, we marked with green in the background where the normal range of each marker, the clinical normal range were set. And then it's also clear that for many markers, all of the people, both the centenarians and the non-centenarians, are way out of that normal range, which a bit tells us that the normal range of biomarkers are typically set for a younger population.
Yeah, and this is interesting. And actually, one of the findings that caught my attention was cholesterol, because you show that in the centenarian population, they were on the high side of cholesterol. So what are your thoughts about that? Why this might be happening?
Yes. So I have received a lot of attention about this cholesterol finding, and it's interesting, I think, because cholesterol, first of all, was not the most important marker of our results. It's rather other markers. It seems to play a pretty small role in this case, but like you say, if any, it seems that the centenarians tend to have higher levels than the opposite. And for us, it's not so surprising working with old age health, because it seems that cholesterol is such a marker that it's very different if you have high levels in younger ages than in old age. And also the clinicians we work with confirm that in old age, a lowering of cholesterol is also typically a sign of your health is degenerating. And you need a high cholesterol. The brain needs a high cholesterol at old age. So it's not necessarily something good to have a low cholesterol in old age.
That's very, very important to have into account, because sometimes we become too rigid with the laboratory results, and sometimes we have to understand the different nuances and how those values may change as you age and are not necessarily bad for your health. Actually, at some point, as you mentioned, the change in cholesterol in the other direction may be problematic rather than beneficial. So you run a cluster analysis, and I saw that for centenarians themselves, where you were able to identify like two different groups. Can you tell us a little bit more about that?
Right. So the first part of the paper, we look at each marker specifically, and we compare long-lived people with non-long-lived people. And in the second part, we conduct this cluster analysis to look at, in the centenarian group, is this group an homogeneous group, or do we see many clusters of distribution of biomarkers? And we end up with finding only two groups or two clusters. And these two clusters also seem rather similar. So our main conclusion, or overall conclusion, is anyway that centenarians tend to be rather homogeneous group based on these markers at least. But they do differ a little bit with one group. It's about 50-50% of them in each of the group. And one group tend to be a little more similar to the non-centenarians, whereas the other group tend to be somewhat healthier than the other, in that, for example, having lower level of uric acid and glucose and these values. However, only two of the markers were statistically significantly different between the two clusters of centenarians.
Which markers?
Shun, if you are quicker than me, you can answer these details.
Yeah, we observed difference at first albumin, and also we observed the difference TIBC, total iron binding capacity, and we also
Okay, so yeah, and it's interesting, and I'm going to focus now on albumin. Did you observe significant differences between centenarians and non-centenarians in albumin?
you can answer, Shun.
So-
Did you say between centenarians and non-centenarians?
Correct, for albumin.
Yes.
Yeah, we
No.
did not observe the difference in
Okay,
albumin between centenarian and non-centenarian.
And because initially when I read the article the first time, I was particularly interested in albumin because I tend to think that as you get older, the protein level is decreasing, and is going to ultimately contribute to like deterioration of your health. So the fact that you had this finding is intriguing. And I want to link it to changes in hepatic function. So what happens with the hepatic function as you become a centenarian when you analyze aspartate aminotransferase and alanine aminotransferase is the relationship between the two for two reasons. First, nutrition, and second, access to alcohol as well. So what are your thoughts if you put all these together?
Yes, I mean, first we have to clarify that neither Shun nor me is a medical doctor. So these thoughts were more developed by the medical doctor in the paper, but we try our best to develop this a little bit. But you're right that this was intriguing, and some of the markers, I mean, they can be seen as markers of both liver function or metabolic function, and it's a little bit difficult to know exactly what they mirror. But if we start with the albumin, that you say, I mean, at the one hand, what you say that when people age, it can change, and that may well be, but now we compare them at very similar ages. Having said that, it can of course be a marker of biological age, so that you would expect that someone living much longer at a given age of 60 or 70 have a better value. But this we could not observe in this comparison. And the second thing I want to say is that what we did not do in this study, and I think what is a natural step forward, is to combine the markers. So we have here analyzed them very separately for each person. And I think combining 2, 3, 4 of these values that we think work together somehow in single individuals is quite interesting. So if you have beneficial values of 3 or 4 markers, how is that compared to having adverse levels in the other 3, whereas one is normal, for example? And this we haven't done yet.
Yeah, and it's definitely a subject for future research to characterize it better, right?
Mm.
The next question is related to the fact that there are multiple studies showing that caloric restriction is associated with longevity. And on the other hand, inflammation has been the culprit for many diseases and also is associated with aging. So based on the biomarkers, do you think that being able to become a centenarian has more to do with nutritional factors or inflammatory factors?
It's very difficult to say. I think both play a role, but personally, I would think that caloric restriction is maybe one of those factors that is more important in certain age spans for future health, whereas inflammation is something that at any time point is important, if you see what I mean. For example, if we compare to cholesterol or obesity or BMI, we know it's typically good for you to keep that in shape early on in the life course. but when you become very old, it's good for you to have some metabolic reserve and to have some body mass fat even at old age. So perhaps caloric restriction is working like that as well. I haven't seen any study really exploring this in different phases, but inflammation is. I have not seen any evidence that this should not be important at every time point.
Yeah, and I find very valuable the work that you guys did because you are focusing on biomarkers, and I think this is going to be the first step to start making clinical correlations between these biomarkers and what is happening throughout time as you age, and I think this is very valuable, as I said before. I am curious, Dr. Murata, because you are running like a parallel study comparing the Swedish population with the Japanese population. So, as a way to give us some background, what are the main differences that make you think that the situation may be different between the two countries?
Yeah, so that project, so comparing Swedish older people and Japanese older people. So we have just started that project, and we are still trying to find some difference. But yeah, so yeah, like that. So
and are there like differences that between the two populations as they age that make you think or that this is, you know, that this is something that is worth addressing? So is there more likelihood for you to become a centenarian in Japan compared to Sweden?
yeah, it is reported that so Japanese people are likely to be centenarians than Swedish people. And yeah, now what I am investigating is that so my hypothesis is Japanese people live longer with some disability and care. So Japanese people, of course, so it is reported that so longevity is so good, best in Japan. But and also some Japanese medical doctor and some care workers suggested that so assumed that expected that so Japanese people live with disability. So it means after some small study suggested the proportion of older people with bedridden is higher in Japanese older people than other European country older people. So yeah, as a start of our project, we are trying to investigate the proportion of this. So we are trying to compare the mortality with disability between Japanese and Swedish older people. So it's we have just studied, and yeah, now we are trying to see that.
Excellent. So it's going to be very interesting to see the results of that study. So let's go back to this one. So there are definitely some strengths related to the paper. The fact that the size of the cohort is kind of unique. This is the first study focusing on biomarkers in this particular population, and that in itself provides some robustness. But let's talk about the limitations. So what things you think can be like fixed or done better in the future to close the knowledge gaps about this topic?
Yes, so like I said, that this is the very first study we do on this cohort on centenarians. So we see this not as a closing mark, but as a start. So many things can be done, and one natural step is, of course, to combine markers in one individual and not look at them separately. This is very important and interesting, I think. Something else that a lot of people comment is that we don't have lifestyle factors. We do have some, but not fully. And this, I think, is interesting because at the one hand, these biomarkers are the consequences of lifestyle. And on the other hand, lifestyle can modify them afterwards. But it's not, for me, it's not completely easy to say that we should just adjust for all the lifestyle factors, because they are part of what we present here. But I still think it would be interesting to have a more longitudinal perspective. So not only, like here, look at the first marker, but also study the change in a marker. So is the change a consequence of the biological age ticking and determining something, or is the biological clock sort of driving the change? And this is, of course, very difficult to sort out, but we would like to at least dig more into the longitudinal perspective of how markers develop, but also perhaps, if we can, how other diseases or other lifestyle factors interact with this development.
Absolutely, absolutely. So what do you think is the main takeaway of your paper for our audience?
I think it is that already at ages 60 or 70 or many years prior death, we can observe a difference in these biomarker profiles and the markers we see between people that become eventually 100 and shorter lives. And in the appendix, we also see that this goes if you compare 90-year-olds to 80-year-olds and so on. And this speaks, I think, against that it is pure chance that makes you become 100 years. It makes a difference, and for some markers more than others. We see, for example, that people with very high glucose values, none of them reach very high old age. So it speaks against pure chance, and partly this was a little surprising to me, because I thought that at some point chance would play a larger role. But on the other hand, we can also say that the differences we find are not huge. So it cannot rule out also genetics and chance, but markers do matter.
Yeah, and probably in the future some interventions, right, to try to, for those who are not part of that select group, because they are already exhibiting some changes in biomarkers, potentially bring them in line to see if that in itself is able to affect the longevity, and that's something probably that's going to be the subject for future research. But this finding and the message you just sent is very clear, and is definitely something that your paper is adding to the current knowledge. And I appreciate you guys coming today to discuss this with me. It was really a pleasure having you here, and I learned a lot based on your findings, and we will definitely follow up on the research that you both are producing. And I am particularly curious about Dr. Murata's approach comparing the two populations of Sweden and Japan. Thank you so much for coming today. It was a pleasure having you here.
Thank you so much for the invitation. Thank you.
Thank you.
Thank you. So for our audience, the link to the paper is going to be found in the description of the video, and don't forget to leave us your feedback. See you in the next episode.